Hello, greeting to both of our panel. So I will introduce myself. My name is June Endthyana Anak Janis. I'm a matrix number ECE18032. So right now I will present to you my final year project one, which I have chosen the title of Autonomous Marine Surface Vehicle for Oil Spill Cleaning. So my supervisor that supervised me for this final year project is Prof.Dr. Mohammad Faiz Liew bin Abdullah. So so right now I will proceed to the first part for this presentations, which is the introductions. So as you can see here, this is from the first picture, we can see that the oil spill in the oceans. So oil contaminations is a persistent issue in the marine environment. Despite essential technical advancements in the safety of crude oil and gas extractions and transportations, oil spill continues to pose a threat to the marine environment. So these disasters have wreaked the havoc on marine and coastal ecosystem as well as the organisms that support them for decades. Release of crude oil from tanker offshore platform and also wells as well as the spills of refined petroleum products such as gasolines and diesel and thereby products heavier fuel used by large ships such as bunker fuel or the spill of any oily refuse or waste oil can cause all the oil spill. So the type of oil spill, the temperature of the water affecting the evaporations and biodegradations, and sort of the shoreline, and beaches involve or plays role in the cleanup and recovery process. Spill cleanup and can take weeks, months, and even years. So autonomous marine surface vehicle (AMSV) for oil spill cleaning that I will do for this final year project is a device that can collect all the oil, such as lubricant oil from the car and also other vehicles, especially in the vehicles that in the water or oceans, such as ship, boat, and so on. So this project was made to clean up the oil spill, especially in the shallow water area. As before this, oil spill in the oceans are taken into account. So mainly this AMSP is more focused on the shallow water. So the spectroscopy methods will be applied in this project to detect the oil if it cannot be seen by using the naked eyes. So in this project, the UV sensor will be used to detect the wavelength for UV visions. So the wavelength range for the UV visions is from 190 to 800 nanometer. Once the UV sensor detects the wavelength range of the oil, the information will receive by the controller, which is the smartphone, Android smartphone. So for this, I will continue to the next part. So for this project, we will apply the addition principle to pick up the oil from the water. As you can see here, I will use the belt schema. I will use the design of the belt schema to pick up the oil from the water surface. So as you can see, I will use the solvent here. The solvent oil only solvent. So what is solvent? Solvent are strewn materials that are strewn around the oil surface. The solvents are retrieved when the set amount of time has passed after the absorption process began. So the solvent are retrieved when the set amount of the time has passed after the absorption process began. So floating carriers will equip uh, So as you can see that the solvent are retrieved when a set amount of time is passed after absorption process began. A floating carrier will equip with the drum like as you can see in here. As you can see here, this is what I want to explain here is the So the solvent are retrieved when the set amount of time has passed after the absorption process began. So floating carrier will be equipped with a drum-like pickup system, just like this one. A massive of plated adhesive patches will be circulated through the oil layer, absorbing the quantity of oil that they are capable of based on their physical quantities. So for this one, I will not use this one, but I will use the oil only solvent pad here. So so the oil is either pumped directly to auxiliary vessel or the intermediate storage tank. So after the solvent is absorbed the oil from the water surface, it will store the dirty solvent pad into the store tank that I will design, that I will put in the AMSP. So the oil only solvent pad can be used to skim oil from the water because the oil absorbed to the solvent fibers while the water is repelled by the pad. So this AMSP is applied it will be applied the concept of catamaran design. So what is catamaran design? As you can see here, it have two hues, which it make it more stable rather than by using only one hue. So so basically I will use two propeller to operate this AMSV. So I will continue to the next one, which is the objective for this project. So the first objective is the first objective for this project is to propose an AMSP unit using Ubvis Sensor to detect and clean oil spill. So as you can see that we will use the Ubvis Sensor as our sensing unit for this project. And the next one is to integrate and propose the AMSP system with the mobile handphone using Bluetooth 5.0. So we will use, especially we will use the Android smartphone as our controller for this AMSP. And the next one is to test the functionality of the integrated system. As you can see that this project is the development from the previous study. So for this project, we're hoping for the good result for this AMSV. So I will proceed to the next part. So the next part is the scope of work for this project. So this project will develop by proposing the marine vehicle to be used as the oil spill cleaning device, which can be controlled by the technology, which is the Android smartphone. So this AMSV is mainly focused on the shallow water area. For the main components of the circuit, it will use the Android Arduino Uno HC05 Bluetooth module, a pair of hues, which consists of two propellers, and UV visions, which used to detect the water surface, to detect the oil from the water surface, and the conveyor like oil solvent mechanism and suitable power supply 9 to 12 volts. So as this AMSV will be using HC05 module, it can move range below 100 meters from the controller, which is Android smartphone. So the oil can be trapped by using the solvent materials, which is the oil on the solvent pad is less than 1 kilogram. Hence, the timer will be used to set the time limit for the solvent to absorb the oil from the water surface. So right now, we will proceed to the next part. So as you can see here, from the sensing unit, it will go to the microcontroller, and our microcontroller, which is the smartphone, and the motor control unit in the AMSV, and our motor drive unit is the mechanisms that will move the oil on the solvent pad, and the display unit is we will use the LCD to display the informations of the AMSV, especially the UV part for the UV informations. And our communication unit is a smartphone, which is the Android smartphone. So based on the flow chart, it is showing how the circuit of the AMSV system works. When the AMSV is put in the water, the UV vision sensor will be used to detect oil in the water, and it will turn on the oil solvent conveyor or mechanism to move So after that, the timer will count until 30 seconds for the solvent material to absorb the oil from the water surface. So once the timer completes 30 seconds, the dirty solvent will roll into the waste container. So it will move by the roller conveyor-like concept. By using the roller conveyor-like concept, so this AMSV then move to the another area and repeat the same process again. So we will proceed to the next part. The next flow chart is about the fusion of the autonomous marine surface vehicle. So this is the more to the how the autonomous marine surface vehicle work. So I will explain to you. So the serial data is sent to the Bluetooth module HC05 after the on button on the Android app is pressed. So the apps then so the HSC is your Bluetooth. A module is as you can see that the Bluetooth module HC05 Bluetooth module is the serial communications device. So the apps that we created in the smartphone by using the coding of software coding that I will do it by using my MIT software. We'll send the data to the Arduino experience via Bluetooth module, transmit the thing. So the data is received, is checked by the Arduino code. So the LED turns on if the received data is 1 and it will turn off if the received data is 0. So if the on is being detected, the conveyor-like also one mechanism will work and it will stop for once the timer achieve 30 seconds. So if the AMSP will not detect oil on the water surface, it will go to another area which is moved by using the Android smartphone as it is the controller of this AMSP. And the sensor will do it work and it will repeat the same process until the water surface is clean. So I will proceed to the next one. So this is the block diagram of the project. So as you can see that the upgraded of the autonomous AMSV has functioned to clean the oil spill in the shallow water area by using the environment-friendly material, which is the oil-only solvent pad that I have shown before this. So this project is developed in order to help humans from expose themselves to harm in case there are oil spill in the river. So as you can see here, the project block diagram is described here. We can see that firstly, there is battery to support the circuit of the AMSV functions. So this AMSV project, Android smartphone, will play the important role as it controls the AMSV. So in the circuit, it has the Arduino Uno as the that is connected to the sensing unit, which is the UV vision sensor. Beside that, the propeller is moved once the Bluetooth module connected to the smartphone. So the conveyor-like or solvent mechanism will work once the sensor detect the oil on the water surface. So this AMSP concept is inspired by the catamaran boat that consists of two hulls, which make this AMSP is stable once it is used to clean the oil spill in the water. So I will proceed to the next part. Here, this is the main component for the autonomous marine surface vehicle. As you can see that the first one, this is the most important thing in the sensing unit. So the UVVIS sensor that will be used in this project is GUVA S12ST. So it can detect the UV light in 240 nanometer until 370 nanometer range. So this analog voltage output proportional to the UV index of UV light falling on the detector. So this sensor is a true detector that only detects light from 240 nanometer to 370 nanometer, which is the UVB and most of the UVA spectrums. So it is also picks up the upper end of the UVC. So this sensor will be used to detect oil on the water surface for this project. So the next one is the Bluetooth module, which is it, namely Bluetooth module C05. So by pressing the on button on the Android apps for this AMSV, the serial data is sent to the Bluetooth module C05. So because the Bluetooth module C05 is a serial communications device, it receives data from the apps and is sent to the um, Arduino RX pin via Bluetooth module transmitter pin, TX pin. So the data received is checked by the code that has been uploaded into the Arduino. If the data received is 1, the LED will turn on, and if it receives data 0, the LED will turn off. So right now, I will proceed to the next component for this AMSV. So this motor, we will use the DC motor. So this motor is will be connected to the Arduino Uno. So this motor is the most important component to move the conveyor like oil server mechanism. The DC motor will be controlled by using the Arduino. So interface the DC and Arduino Uno board to control the directions whether in counterclockwise or in clockwise directions. So the hash bridge can be used to control the directions of the directions of the two DC motor simultaneously. So the serial monitor Arduino software is used to send the commands for clockwise and counterclockwise rotations. After manipulating the Arduino commands, these commands are passed to the motor controller, which determines the directions of the rotations of the DC motor. So the next part is the solvent. So this project will use an oil-only absorbent pads to absorb the hydrocarbon-based fluids. So in other words, it is the oil. So the oil-only solvents are made from the untreated polypropylene. So what is that? So what is polypropylene? It is a material that repels water and absorbs oil. So the non-woven polypropylene solvents have the high oil absorption capacity while absorbing little water, so making them an ideal for the oil recovery from the water surface. So this is the next one is a 12-volt lithium battery. So this battery will use this AMSV. It is in the 12-volt lithium battery with a nominals of 11.1 volt. So as you can see that this battery will be uh, connected to the whole circuit, to the whole system in for this AMSV. So these battery packs with the best wire length for the space and protections against over voltage, over current, and also overcharge, and also possibly short circuit. So the non-toxic, waste, and safe, dependable, premium environmentally friendly rechargeable. This one is rechargeable battery with a high temperature PVC wrapper. So it will it can be charged, and the long charging cycles and high energy density make it ideal for this long-term daily use. So I will proceed. I will proceed to the next part. So this one is the Propeller that I will use for this project. So I will use two Propeller. As you can see, I have the two hulls as I use the catamaran design. So this propeller shaft will be functions once the AMSV will be put in the water. So this propeller shaft can be working given the power supply 12 volt. So the first one, as you can see here, this is the front view of the AMSV. As you can see here, for the length, I have decided to do it by using for the length. I will try to make it in the 40 centimeter, and for the height, I will try to do it less than 50 centimeter. So as you can see here, the dimensions of the AMSP with the few rules that will be used in this project. So this design is been chosen is because it is more stable compared to the design that using only one fuel. So this one is the back view. I think yeah, this one is the back view. So I will continue to the preliminary result for this AMSV. So this is the connections of the sensing system, which is the main part that have been done for this final year project one. So this is the sensing system of this project. So for the connections, I will connect the UV sensor pin to the ground and to the Arduino pin ground. So the next one is the UV sensor will connect to 3V3 to the Arduino 3.3 board. So the UV sensor pin EN is connected to the Arduino pin 3.3 board. And the UV sensor also will be connected to the analog pin out to the Arduino analog pin. And the Arduino analog pin 1 is connected to the Arduino pin 3.3 board. And the LED display will connected to the VCC at Arduino pin 5 board and also ground to the Arduino pin ground, and it will connect also to SDA to Arduino pin SDA, and also it will connect to SEL to Arduino pin SEL. So the Arduino A0 pin was used to receive the analog output data in this code. So in order to accurately measure the output voltage, we also connected to I also connected the pin A1 to the 3.3 volt power supply, and it used as the reference. So the intensity of the ultraviolet UV, which is in unit milliwatt milliwatt per centimeter square, can be calculated by using the code by measuring the output voltage. So for the coding, I have been done it by using the Arduino. So I think I will proceed to the next one, which is the expected result for this AMSV. So as for the expected result,
As for the expected result, the sensing system is hopefully can be connected to another important part of this autonomous marine space vehicle, such as the conveyor like oil-only solvent mechanism. So I also hope that the control unit is also can be worked, as it is the only way to generate this vehicle. So in this process of doing this hardware, I hope I can find the most suitable power supply to generate this AMSV. So the important thing is I hope that the hull can support the weight of the components and the oil solvents materials, so that this AMSV can be used to clean the oil spill in the shallow water. So I think that's all from me. Thank you.